So today we're going to take a look at a little bit different applications. We're going to look at circular applications. So what I'm looking at, we'll see if I can draw it out first of all. Sorry, let me group those, or flip. Well, we'll just have to redraw it. So much for taking a shortcut. So it looks like that. I got a little bit big there. I'll shrink it down so you can see the whole thing at once for a while. And what we're looking at, this is actually a round part, and this is a cross section cut out of the center of it. We're given 92 millimeters from there to there. We're asked to find, I'm going to change colors here. We're asked to find this angle A for one. We're given 72 millimeters across here, 24 millimeters across there, 26 millimeters here, 16. This angle here is given as 18 degrees. This is given as 28 millimeters. This distance is given as 24. This angle here is 21 degrees, 16 millimeters, and 34 millimeters. So I need to find, first of all, I want to find angle A. I want to find the area of this piece. And then I want to find the volume. If that is a circular piece, I want to find the volume of it. So to find A, well, I know I can find this dimension right here. How can I find that dimension there in green? Well, from here to there is how much? From center out. Better be 36, half of the 72, right? And from here to there is how much? 12, half of the 24. So that green dimension there has to be 36 minus 12, or 24 millimeters. So now we just need to find the blue dimension here. If I knew the whole length of this, I would just subtract 92, wouldn't I? There you go. We've got 16 here, 24 here, 28 and 16. All we're missing is this piece right here. We've got to find that piece. How can we find that piece? Well, 92 goes to here, though, not all the way over. It doesn't necessarily line up with this. We can find this. There's one dimension here that looks like I forgot to give you. This piece here is 28. So we can find that dimension if we knew what this thickness was, right? No, those are not. We do know that from here all the way up to the top is 24 plus 34, or 58. So if I subtract the 28 from that, this 28, that tells me that from here down is 30. So if I just knew this piece to subtract, I could have that height, right? Well, how do I get that piece? So I got over here, this is 26 all the way up. I need to figure out how far it is there. To do that, I am going to be looking at this triangle. Let's pull that out and look at it more closely. I know I have the 18 degrees here. I know I have 28 millimeters here. I need to find this dimension right here. What trig function am I going to use? Yeah, with this angle, the side I have is the adjacent side. The side I'm looking for is the opposite side, so that is a tangent. Definition of tangent is tangent of an angle is opposite over adjacent. So I do know the angle is 18. The opposite side is what I'm looking for. The adjacent side is 28. Since I'm looking for a side, I make it a proportion, I cross multiply and divide. Tangent of 18 times 28 divided by 1. .098. So that height right there is 9.098 millimeters, which makes this here 16.902 millimeters. Since that's 16.902, that makes this, of course, is 16.902 over here as well, just moving it over. From the 30 makes this 13.098. I know this diagram is getting to be kind of a cluster here. So we've got this triangle now that I'm going to look at more closely. 21 degrees. $21 right here. 13.098 millimeters here. I need to find this side. Well, once again, we're looking at a tangent. All the triangles or the... Okay. Whenever I have an angle here with the horizontal, I can complete the right triangle by matching that horizontal up with a vertical dimension. So I found this vertical height here by subtracting dimensions.
Why are you finding those heights?
Well, because I need to know this distance. That distance is this side of this triangle. If I knew the vertical side, I could find the horizontal side because of the angle.
So that was the original question, to find that.
Well, I'm trying to find angle A here.
Yeah.
But to get angle A, I got to know this dimension. So the way I'm finding that dimension is I'm taking this whole length and I'm subtracting the 92. Well, so right now I'm trying to find that whole length. So tangent of 21 degrees The opposite side is 13.098. The adjacent side is what I'm looking for this time. Put this over 1. I cross multiply and divide. So 1 times 13.098 is 13.098 divided by the tangent of 21 degrees. 34.121. 34.121 will go. So this up here, 34.121 millimeters. So we will now add 16, 34.121, 24, 28, and another 16. I get 118.121, is that correct? I think so. So the whole distance here is 118.121 millimeters. If I subtract 92 from that, I'm going to get this distance of 26.121 millimeters. So now I can look at that triangle. And find a, I'm going to pull it out. I've got 24 here, 26.121 here. There's my right angle. Here's the angle A I'm looking for. Once again, this looks like a tangent. Tangent of an angle is opposite over adjacent. This time I do not know the angle. Angle A is what I'm looking for. Opposite is 24, adjacent is 26. Before I punch this in, obviously we know we're going to do an inverse tangent here, because we're looking for an angle. But before I punch this in, can anybody tell me, is this angle more or less than 45 degrees? If this angle is 45 degrees, what do we know about the opposite and the adjacent? They're going to be equal. If this one's smaller, that makes the angle smaller or bigger? Smaller. So when the top number is smaller, when the opposite side is smaller, the angle has to be smaller than 45 degrees. So tangent, second tangent of 24 divided by 26.121, 42.58 degrees. So there we go. We've got 42.58 degrees. Now, with what we've done here so far, we have found all the horizontal and vertical dimensions of every feature. So what I would leave, I'm going to leave it as part of something for you guys to do in the homework. It's going to be to find, now that you have all those horizontal and vertical dimensions, find the area of this shaded piece. So that's going to be that piece and this piece put together. But all you need to do is find the area of one of them and double it, because they are identical. We're going to leave the circular part out of that one for now. So for this next piece, try that again. So I'm going to give you, this is 8 millimeters. This is 42. That's 14. 26. 20. Total length of 78. And total here is 72. And this is 8 here. I want to find angles A, B, C, and I want to find the total volume. This is a turned piece. So pretend it looks symmetrical. So for angle A, I'm going to break A into two pieces, 90 degrees and then this piece. 90 degrees plus whatever this piece is should add up to angle A, correct? So how would I find this piece? We're going to look at that triangle there. This is the angle I'm looking for. What do I know about that triangle? Perfect. 78 is the whole length. So we subtract 8, that's at 70. Subtract 20, that's at 50. Subtract 42, we're at 8 here, right? So this is 8 millimeters. How about this side? Well, what's the radius here? 36. Good. What's the radius have to be here? This is 26 there. That 26 there would go from here to here, right? 36 minus 26 leaves us with 10 there. This is a radius of 4 here, right? So it means that difference has to be 6 millimeters. This angle, bigger or smaller than 45? The opposite side's bigger than the adjacent side, so it's got to be bigger than 45 degrees, right? So we're looking at tangent of our angle. It's opposite over adjacent. Plugging in, we're looking for the angle. Opposite side is 8, adjacent side is 6. So we're going to do an inverse tangent. So second tangent, 8 over 6. 53.13 degrees. So angle A is 90 plus that, 143.13 degrees. Any questions on angle A? So next we're going to look at angle B. If I know angle B, actually angle C will be easy to find, because angle C, this would be angle B up here as well, excuse me. Angle C is this angle plus 180 degrees. This is a straight line across there. So if we know angle B, it'll be easy to find this angle, and we just add that to 180 to find angle C. So let's find angle B. I'm going to use this triangle right here. Here's angle B, here's my right angle. I know this side here is 20, and this side here is this is 14 here, right? So 26 minus 14 makes 12. So B is going to be a tangent again. Opposite over adjacent. We're looking for the angle B. Opposite's 20, adjacent's 12. So B is equal to the inverse tangent of 20 over 12. (59.04 degrees). So angle B is 59.04. If that's 59.04 degrees here, right there, what's this angle have to be? 90 minus that, right? Or 180 minus 90 minus that. That's going to be 30.96 degrees. So this angle right here is also 30.96. So C is just 180 plus that angle. So 180 plus 30.96 is 210.96 degrees. Any questions on where any of those three angles came from? Okay, now to the fun part. Finding volume. There are two pieces here that are going to be easy to do, so we're going to do those first. That's this piece here and this piece here. Remember, this is a turned piece. So what this first piece here is, I'll call this piece 1. It's actually a circle with a diameter of 72 and a height of 8. It's a cylinder. To find the volume of that cylinder, we find the area of the base. The base here is that circle. So the area of the base is pi times what squared? Radius. So pi times 36 squared. (3.14 times 36 squared). 4069.44. That's millimeters squared. So then its volume is that times what? The height of 8 millimeters. So 32,555.52. 32,555.52 millimeters cubed. Next will be this piece here. I'll call this piece 2 for now. That has a radius here we figured out to be 10. And that height or length of 42. So the area of that base is pi times 10 squared, which is 314 millimeters squared, giving us a volume of that 314 millimeters squared times 42 millimeters of height. $13,188 millimeters squared. Now we've got these other two pieces to figure out. This piece here is where we're going to go next. That one, I'm going to draw it. I'm actually going to draw it, I'm going to turn it upright, like this. We know this radius up here is 10. And the radius down here, gotta double check, was 36 minus 14 is 22, right? So that's 22. And the height of this is 20. Now, this is what they call a frustum of a cone. It's a cone with the tip chopped off. There are fancy formulas for finding its volume, but really all they're doing is finding the volume of the whole cone and subtracting the tip that's been chopped off. So what we really need to find is what the height of that full cone would have been. And to do that, we're actually looking at a triangle like this. This triangle has a height of 20, and this is 12 here, right? We want to figure out how big that triangle would have to be, how tall it would have to be here for that base to be 22. So to find this overall height, 22 compares to 12 as x compares to 20. And we'll cross multiply and divide. So 22 times 12 divided, 22 times 20, I should say. 22 times 20 divided by 12. 36.67. So that overall height there would be 36.67 millimeters. So what we're going to do is we're going to find the volume of that full cone. So the volume of that cone, we're going to find the area of the base. The area of the base is pi times 11 squared. $379.94. And then times, the volume will be 379.94, times that height, the 36.67, and since it's a cone, we divide by 3. So it gives us 46, 44, 13. That's millimeters cubed. That would be the volume of the whole cone. Now we need the volume of the little cone that's chopped off. The volume of that little cone, the area of its base, is pi times 10 squared, so that's 314 millimeters squared. So that its volume is going to be that 314 millimeters squared times its height. Well, its height is going to be the 36.67 minus the 20. So that's going to be 16.67. And of course, divided by 3. It's cone. Gives us 1744.79. Millimeters cubed. We subtract those two. Oh, what do we have there? $2899.34 millimeters cubed is going to be the volume of that frustum. So that's the volume of this piece here. Now we're going to do this piece here. So we've got a radius of 10 and a radius of 4 and a height of 8. So we're going to do the exact same thing with it. So this is a radius of 4, radius of 10, height of 8. Finding that volume I'm going to leave as part of your homework. This problem is word for word the second problem on your worksheet. So I'm going to see if you guys can repeat that process I did for finding the volume of, again, the proper term, if you ever want to look it up, there are formulas out there you can look up online. It's the frustum of a cone. Frustum, like I said, just means a cone with the tip cut off of it.
Well, I got hella questions
Yeah?
after we get our worksheets and
Okay.
start working. What do we use the frustum and the cone for when you run the calculator?
If you're doing volumes of parts, like if you have density and you're trying to find, what's the weight of that or mass of that part going to be from its volume. A lot of times when you're turning, there's a lot of things that turn down in your frustum. A plug, if you're looking at like steel spindles and stuff like that. And so right now, most of the examples that are flipping through my head are from woods, like table legs and stuff like that end up being a frustum. Anything that's a taper is a frustum.